Have you ever wondered what lies beneath the ground we walk on? Let's delve into the unseen world beneath our feet. This mysterious realm is made up of various layers, each with its own unique characteristics and qualities. Earth, our home, is not just a simple sphere, but a complex structure of these layers, each one playing a vital role in the planet's overall health and functionality. Starting from the surface, the layer we're most familiar with is the crust. We live on it, build on it, and dig into it. This layer is surprisingly thin, much like the skin of an apple, covering the entire planet. The crust is a solid layer, varying in thickness from 3 to 45 miles. It's composed mainly of rocks like granite and basalt, and it's here where the continents and oceans reside. Beneath the crust, we find the mantle. This layer is divided into two parts, the upper and the lower mantle. Today, we're primarily interested in the upper mantle, which together with the crust forms what we call the lithosphere. This layer, extending to about 60 miles beneath the Earth's surface, is a world of semi-molten rock, or magma. It's not quite solid, but not entirely liquid either. It's in a constant state of flux, moving ever so slowly over millions of years. Now, why are we focusing on the crust and the upper mantle? Because it's within these layers that the action happens. This is where the theory of plate tectonics comes into play. The lithosphere isn't a single unbroken layer. It's broken into enormous slabs or plates. These plates, floating atop the semi-fluid upper mantle, are always moving, albeit at a snail's pace. This movement, fueled by the Earth's internal heat, is responsible for creating mountains, causing earthquakes, and even shaping our continents. The world beneath our feet is constantly changing, evolving and shaping the world above. So the ground beneath us is not as solid and unchanging as we might think. It's a dynamic, ever-evolving world, full of mysteries waiting to be unraveled. This is just the beginning of our journey into the fascinating world of plate tectonics. Imagine, if you will, a great jigsaw puzzle. But this isn't a puzzle you might find in your closet, gathering dust. No, this is a grand, dynamic, and constantly shifting puzzle that spans the entire surface of our planet. Welcome to the world of tectonic plates. These plates are colossal. They range in size, with some as small as a few hundred miles across, while others span thousands of miles. Yet, no matter their size, each one plays a critical role in shaping the Earth's surface. They are the architects of our world, creating mountains, carving out ocean basins, and giving birth to whole continents. Think of these tectonic plates as the Earth's skin, a hard outer shell protecting the squishy, hot interior. This shell isn't a single piece, but is broken into several large and small pieces. These plates are what we're talking about. Now you might be wondering, how many of these plates are there? Well, there are 7 major plates and numerous minor ones. The major ones you might have heard of, like the Pacific Plate, the North American Plate, or the Eurasian Plate. But whether major or minor, each plate has a significant role to play. And here's the fascinating part. These plates aren't static. They're always on the move, albeit at a pace slower than a snail's. They slide past one another, crash into each other, and sometimes even get forced beneath their neighbors in a process called subduction. This constant motion, this endless dance of the plates is what shapes our world. It's an incredible thought, isn't it? The ground beneath our feet, the mountains that tower above us, the oceans that stretch as far as the eye can see, all are the result of these moving plates. So, our Earth is like a magnificent puzzle, constantly moving and reshaping itself. And just like in any puzzle, each piece, each plate, has a crucial role to play in creating the beautiful, dynamic world we call home. Now, what could possibly be powerful enough to move these giant puzzle pieces? Well, the answer lies hidden in the depths of our planet. 3 primary forces drive the motion of tectonic plates: mantle convection, slab pull, and ridge push. Imagine a pot of soup simmering on a stove. The heat from the burner causes the soup at the bottom of the pot to warm up and become less dense. This warmer soup rises to the surface, displaces the cooler soup, which then sinks to the bottom, gets heated, and the cycle continues. This process is similar to mantle convection. The Earth's mantle behaves like a giant pot of soup heated by the core. The warmer, less dense material rises towards the crust, cools down, and then sinks back down, creating a continuous cycle of motion that propels the tectonic plates. Now let's move on to slab pull. Picture a tug-of-war contest. On one side, you have a team of strong, robust people. On the other side, you have a team that's not as strong. Which side do you think is going to win? The stronger team, right? In the context of plate tectonics, the oceanic plates are the stronger team. They're denser and heavier than continental plates, and as they sink into the mantle at subduction zones, they pull the rest of the plate along with them. This is slab pull, and it's considered the most influential force in plate tectonics. Lastly, there's ridge push. This is like the force you apply when you're sliding a heavy box across the floor. At mid-ocean ridges, newly formed lithosphere slides away from the elevated ridge, pushing the rest of the plate along. So, the plates are not just drifting aimlessly, but are driven by powerful forces deep within the Earth. These forces, while invisible to us, play a crucial role in shaping the surface of our planet, constantly remolding and reshaping it like a master sculptor at work. What happens when these giant puzzle pieces collide? Imagine two colossal slabs of Earth's lithosphere, each several miles thick, crashing together with unfathomable force. This is not the stuff of science fiction, but a reality happening beneath our feet. When these tectonic plates meet, they form what we call plate boundaries. And it's at these boundaries where some of Earth's most dramatic geological events occur. There are three primary types of plate boundaries: convergent, divergent, and transform. Each type is defined by the way the plates move relative to one another, and each creates unique geological features and phenomena. Convergent boundaries are formed when two plates collide head-on. Depending on the types of plates involved, this can lead to the formation of mountain ranges, like the majestic Himalayas, or deep-sea trenches, like the Mariana Trench in the Pacific. This is also where we find some of the most intense seismic and volcanic activity. Divergent boundaries, on the other hand, occur when two plates move apart. This creates a gap, allowing molten rock from deep within the Earth's mantle to rise, cool, and form new crust. This is how the Mid-Atlantic Ridge, an underwater mountain range that spans the entire length of the Atlantic Ocean, was formed. Lastly, we have transform boundaries. Here, plates slide past each other horizontally. This lateral movement can cause intense seismic activity. The infamous San Andreas Fault in California is a prime example of a transform boundary. But these boundaries aren't just about creating mountains and causing earthquakes. They're part of a continuous cycle of crust creation and destruction that shapes our world and drives its geological evolution. Over millions of years, these forces have sculpted the Earth's surface into the diverse and dynamic landscape we see today. Thus, the movement and interaction of these plates can create some of the Earth's most dramatic and powerful events. So, the next time you marvel at a mountain peak or feel the ground shake beneath your feet, remember the immense power of plate tectonics at work. But how do we know all of this? What is the evidence for plate tectonics? The theory of plate tectonics is not just a wild guess. It is a well-substantiated explanation of the Earth's structure, backed by a body of evidence collected over many years. Let's dive into some of the compelling pieces of evidence that support this theory. First off, let's look at the continents. Have you ever noticed how the east coast of South America and the west coast of Africa seem to fit together like puzzle pieces? This observation, known as continental drift, was first made by Alfred Wegener in the early 20th century. It suggests that the continents were once joined together in a supercontinent, which we call Pangaea, and have since drifted apart. Next up, we have the distribution of fossils. It's fascinating to note that identical fossils of ancient plants and animals have been found on continents that are now thousands of miles apart. For instance, fossils of the Mesosaurus, a freshwater reptile, have been discovered in both South America and Africa. The most plausible explanation: these continents were once connected. But hold on, there's more. One of the most compelling pieces of evidence comes from the magnetic stripes on the ocean floor. These stripes are the result of the Earth's magnetic field flipping back and forth over millions of years. As new oceanic crust forms at mid-ocean ridges and slowly moves away, it records the Earth's magnetic field at the time of its formation. The pattern of these magnetic stripes provides a kind of barcode that matches on either side of the mid-ocean ridge, suggesting that the seafloor has been spreading over time. These are just a few examples, but the evidence for plate tectonics is abundant and varied, coming from multiple fields of scientific study. Each piece of evidence strengthens the case for this grand theory that explains so much about our Earth. So, the evidence for plate tectonics is all around us, if we know where and how to look. How does the movement of these plates affect life on Earth, you may wonder? Well, the impact is far-reaching, influencing everything from the air we breathe to the ground beneath our feet. Plate tectonics is like the grand architect of Earth, designing a diverse array of habitats for life. When tectonic plates separate, they form rift valleys and deep sea trenches, creating unique habitats for creatures adapted to extreme conditions. On the other hand, where plates collide, they push up mountain ranges, providing habitats for species that thrive in high altitudes. These diverse environments, in turn, foster biological diversity, the very essence of life on Earth. But the influence of plate tectonics extends beyond the creation of habitats. It also plays a crucial role in the distribution of resources. The movement of these colossal plates has shaped the distribution of minerals and fossil fuels, vital for human civilization. For instance, the formation of coal deposits, a crucial energy source, is intimately linked to the historical movements of tectonic plates. Similarly, the shifting of these plates over geologic time has influenced the distribution of fertile soils, impacting agriculture and consequently human survival. However, the impact of plate tectonics isn't always so benign. The movement of these plates also brings with it a risk of natural disasters. Earthquakes, tsunamis, and volcanic eruptions are all byproducts of the restless dance of tectonic plates. These disasters can cause immense loss of life and property, reminding us of the immense power that lies beneath our feet. Yet even these destructive events play a role in shaping life. Volcanic eruptions, for example, can produce fertile soils that enable lush ecosystems to flourish. So even in destruction, there is the potential for creation. So plate tectonics is not just a geological phenomenon, but a force that shapes life on Earth in profound ways. It's a constant reminder of the dynamic nature of our planet, a testament to the intricate interplay between the geosphere and the biosphere. It truly is a force of nature that impacts us in ways more than we often realize. What does the future hold for the Earth's plates? Now that's a question that sparks the curiosity of geologists and earth science enthusiasts alike. The future of plate tectonics is as fascinating as its past, with the Earth's surface continually reshaping itself in an endless dance of creation and destruction. One of the most significant trends we're observing is the movement of the tectonic plates. These vast slabs of Earth's lithosphere are always on the move, albeit at a glacial pace. It's a bit like watching the hour hand on a clock. You won't see it move if you're constantly watching, but leave for a while and you'll notice the change. Consider the Atlantic Ocean, for instance. It's growing wider each year by a few centimeters as the Eurasian and North American plates drift apart. This has been going on for millions of years, and it's predicted to continue into the foreseeable future. In stark contrast, the Pacific Ocean, with its many subduction zones, is shrinking. These movements have the potential to drastically reshape the continents and oceans as we know them. But what about the more dramatic events, like earthquakes and volcanic eruptions? Well, as long as the plates continue to interact at their boundaries, these phenomena will persist. Earthquakes in particular are a direct result of the tension that builds up as plates grind against each other. Volcanoes, on the other hand, are often a byproduct of subduction zones where one plate is forced beneath another. Yet, these changes won't happen overnight. We're talking about processes that take place over millions of years. It's a slow, gradual evolution, but it's one that has major implications for the future of our planet. So, let's wrap this up. The future of plate tectonics. It's a world of shifting continents, rising mountains, deepening ocean trenches, and active volcanoes. It's a future of change, driven by the ceaseless movement of the Earth's plates. So, the Earth is constantly evolving, and the movement of its plates will continue to shape its future. So why does all of this matter? Why should we care about plate tectonics? Well, plate tectonics is, in essence, the heartbeat of our planet. It's the driving force behind many of the Earth's key systems and features, from the towering peaks of the Himalayas to the deep abyss of the Mariana Trench, from the rolling plains of the Midwest to the rugged coastlines of California. Plate tectonics has shaped and continues to shape our world's surface in ways that are both dramatic and subtle. But the influence of plate tectonics extends well beyond just the physical landscape. It plays a significant role in climate and weather patterns, influencing where rain falls, where deserts form, and where hurricanes take their course. It's also a major factor in the distribution of natural resources. Oil, coal, precious metals, these are all concentrated in specific areas because of the movements and interactions of tectonic plates over millions of years. Moreover, plate tectonics is a key player in the grand theater of life itself. It has driven the evolution and extinction of species, creating isolated landmasses and deep ocean trenches that serve as unique habitats. It has shaped the course of human history, determining where civilizations rose and fell, where cities were built, and where wars were fought. Yet plate tectonics also poses immense challenges for humanity. Earthquakes, volcanic eruptions, tsunamis. These are all born from the ceaseless movement of the Earth's plates. Understanding these natural disasters, predicting where and when they might occur, and mitigating their impacts, these are all tasks that hinge on our understanding of plate tectonics. So, in essence, plate tectonics is a window into the past, an artist of the present, and a prophet of the future. It tells us where we've come from, shapes where we are, and guides where we're going. It's the grand narrative of our planet, written in stone and fire and water. So understanding plate tectonics is key to understanding our world and our place in it. So, we've taken a journey from the surface of the Earth to its inner depths, and back again. We've traversed the hidden realm beneath our feet, where the enigmatic dance of tectonic plates shapes the world as we know it. Let's take a moment to reflect on what we've learned. We began by unraveling the great puzzle of the Earth's crust, a colossal jigsaw puzzle of sorts, comprising numerous large and small pieces, the tectonic plates. These plates, we discovered, are not static, but in a state of perpetual motion, driven by the immense forces that originate deep within the Earth's mantle. We delved into the dramatic encounters that transpire when these plates meet. Some collide head-on, giving rise to majestic mountain ranges. Others part ways, creating vast oceanic trenches and rift valleys. And when they slide past one another, the resulting friction can unleash energy in the form of earthquakes. We pondered over the compelling evidence that supports the theory of plate tectonics, seafloor spreading, the fascinating phenomenon of continents drifting apart, magnetic stripes on ocean floors, a testament to the Earth's magnetic field flip-flopping over millions of years, and the distribution of fossils across disparate continents, a clue that once upon a time, these landmasses were joined together. We explored how plate tectonics has profoundly impacted life on Earth. It has driven evolution, influenced climate, and even shaped human history. We also peered into the future, contemplating the ongoing shifts of these plates and the new world they will eventually mold. But perhaps the most significant takeaway is the realization of our existence in a dynamic world. A world that is constantly changing, evolving, and reshaping itself. A world where even the solid ground beneath our feet is merely a temporary arrangement, a snapshot in the grand timeline of Earth's history. Next time you walk on solid ground, remember the unseen world beneath your feet, constantly moving and reshaping our Earth.